Hello, testing, testing. Hello, hello. Bam, I am here. Hello, how's it going? Happy New Year? I think this is the first stream of the year. So hello, how you doing? It feels like so long since I've done any Leetcoding on this channel. Okay, for context, I have a connection who recently interviewed at Oracle, and they tipped me on the questions that they were asked during the interview, so I will try them too and see if I would have passed the interview, or would I need to I don't know, look at the answers. So I was given 3 questions from Oracle from the interview that the connection went to. So we're probably going to do max 2 on this stream, and then the third one we're going to do in another stream. Yeah. So first one is, well, so disclaimer, I couldn't find exactly the exact same questions, but I found similar questions, so they should be still pretty much the same though. Okay, first question. First unique character in a string. Given a string S, find the first non-repeating character in it and return its index. If it does not exist, return -1. Okay, so you're given a string. Get on my pen. You're given a string like Leetcode. You're supposed to find the first character that does not repeat. So in this case, it's L, since it doesn't appear anywhere else. So what if L does not exist? What if it's just Leetcode? E would not be right because it duplicates twice, so T would be our answer. Yeah. Love Leetcode. Wait, return its index. Ooh. 1012 V, so it's V over here. That does not repeat because L repeats here and here. O repeats here and here. Yeah, so the first one is V. And then AABB -1, huh? Okay. Okay, so this is an easy problem, which means I probably shouldn't overthink this, right? I think what we should do is we have to count up the counts of each letter, right? Maybe we can have a dictionary that maps like L to 1, E to 2, etc. And then we're supposed to return its index, huh? Oh, this might be trickier than I thought. Oh no, my prospect said Oracle. So obviously, we can iterate through it once. The letters with count 1 are obviously what we're looking for. But now we're supposed to find the first non-repeating character in it. Oh wait, I know. Can't we just iterate once through it? Get all the counts of all the letters, and then iterate one more time? And then for each letter that you see first, keep track of the index, and if its count is equal to 1, then return its index. Yeah, I feel like that's it, no? You iterate 2 times, so it's O of n time. Is it possible to do this with just O of n? Okay, let's challenge ourselves for a second. Can we do this in one pass? Is it possible to do this problem in one pass? So obviously I need to count up all the characters. Could we somehow keep track of... Maybe we have a collection of all the letters, like Leetcode, and then as we count them up in our first pass, we can maybe remove them somehow. If we see that their count is more than 1. So as soon as we see that E is 2, we were like, okay, remove that. Okay, here's the problem. If we're going to maintain some sort of thing like this, we need it to be like O of 1 axis time for each letter, or else it will not be O of n time. It's going to be like n squared time. O of 1 would be like a set, right? Oh gosh. But then a set is not ordered. Yeah, a set does not keep track of order, huh? How would we keep track of order? Would we store like L index 0 or something like that? I don't know. I feel like we have to do 2 passes, right? Maybe I'll just implement the 2-pass one first, the 2-pass solution first, and then I'll peek at the solution to see if there's a 1-pass solution. So my solution currently is iterate 1 time, count up the counts of each of the letters, and then do another pass, keeping track of the index and the current letter. And if you see that the current letter, looking at the map of counts, has count 1, then return the current index. Yeah, that's my strat. Okay, here we go. How do I exit this pen tool again? Oh no, it's been way too long. Hello? Pointer, oh, it's X. Oh, I feel like I haven't streamed Leetcoding in so long. Okay. It's time to start coding. Okay, so we're gonna make a dictionary first. Counts is equal to... Is that how you make a dictionary, or is this how you make a dictionary? I think that's how you make a dictionary. Oh, this is bad, I'm forgetting everything. Python dictionary instantiation. Curly braces. Oh, it's the set that has a constructor, huh? Bam. There's my dictionary. Okay, now iterate through every single letter. For every... Well, there's a Python has a counts class, doesn't it? But I've totally forgot to use it. It's okay, I can do it manually. For every single character in string, counts C is equal to counts.get C, or default to 0 plus 1. And then we're going to do another pass. I'm just going to assume the dictionary is complete. Actually, you know what? It doesn't hurt to do a sanity check. Print counts. And then we're going to return a bogus value. Run this thing. Leetcode, L is 1, E is 3. Okay. Counting is working. Okay. Yeah, and then all we have to do is iterate one more time, right? And then keep track of the indices. And the first character that we see with count 1, we just return that index. So for I in range. Can I do that fancy thing where they do like for I, comma, character in enumerate string? How do you do enumerate? Python enumerate. For index, comma, fruit. Yeah, that's how you do it. For I and character in enumerate, if count C is equal to 1, just 1, then you return I, else you return -1. Forgot the colon. There we go. Submit. Hey, let's go. It's Arbit is high. Hello, it's Arbit. How you doing? I want to take a peek at the solution. Is it possible to do this in one pass? Or can I just take a look at the other people's solutions? What are the top people doing? Okay. So they have a map. They have a set of everything they've seen. Ooh, it looks like it's one pass actually. For every index and character in S, if character has not been seen, can we use Q for that question? How do we use Q for this question? I don't know actually. How would you use Q for this question? What are they doing here? If the character has not been seen before, then scene.add character. Unique map character is equal to idx true. Unique map character is equal to idx false. Unique ID is equal to list. Key value pair for key value pair and unique map to items if the VI is true. I see. So they're making a map where they set the character to false if it's been seen multiple times. And then they iterate through the list one more time to Oh my goodness. This is not even O of n time. So they iterate once to compute the map of characters to Boolean values. And then this has to be one more pass, right? This is another pass to filter by only the true values to get only the characters that appear only once. And then they do a sorted. This is n log n time. So if the unique characters, if the list of unique characters is equal to 0, then return -1. Else you gotta sort all the keys. Oh my gosh. Oh, I see. Dang it. They're doing the cheat thing where they write 0 milliseconds. Initially, I thought you were going to solve database problems after seeing the thumbnail. Oh. No. I'm doing Leetcode problems. Yeah. I have a connection who recently interviewed at Oracle, and he gave me the list of questions that they asked him, so that's what I'm doing. I'm so curious, is it possible to do this in one pass? I don't think so, right? Because you have to know the counts of all the characters, right? Wait, that's one pass. I don't know. Let me log into my brother's account. And because he has premium. Edge. Let's bring up Microsoft Edge here. Okay, we're on Leetcode Premium now. Linear time solution. Oh my god, there's a linear time solution? Oh yeah, there's a linear time solution. We go through the string lane 2 times. Oh, okay, I got the best solution then. You have to go through it 2 times. Build a hash map, character, how often it appears, and then you iterate another time. Oh, this is how you do it. Collections.counter. Okay, I guess we did it. It was that simple, I guess. Next problem. Okay, so the next problem I got was a linked list problem. Given a linked list, return reference to head after removing certain nodes. Leetcode, given a linked list, return reference to head after removing all even valued. Close enough. Can we solve it in one pass only? I'm not sure, can you? I can't think of a way to solve it one pass. What about other people here? So they put into, no, this is also, they put everything into a counter thing. I should probably remember this pattern, huh? This seems really useful. Collections.counter s. Should I write this down? This seems awfully convenient. Counter, oh, I've already written it down actually. I just did not recall it. I feel like you need to, no? This guy is also, for I enumerate I, if I is in, so you, this one iteration, this one is another iteration. Wait, list hash map.value 0, if hash map else 1. converting your hash map to a list surely is O of n time, right? Yeah, I think so. Yeah, I think this is 2 passes still. Wait, hold on. They have a hash map for every index and character in the string. If C is in if the character is in the deleted set, then pass. Else if hash map that gets C is not none. Hash map that pop C, deleted set dot C. Else hash map C is equal to I. Oh, interesting. Hash map that values. Now this conversion has to be O of n time, right? Converting a hash map values to a list. Because hash map is not sorted by default, right? It's not guaranteed. This seems... Yeah, this is still 2n time, right? Alright, next problem. Remove linked list elements, remove nodes from linked list. Medium problem. You are given the head of a linked list, remove every node which has node with the greater value anywhere to the right side of it. Should we do this one? This wasn't exactly the problem I wrote down. This one is closer, but I already solved it. When did I solve this one? November 2020. Oh, a year ago. 2 years ago. A year ago. More like a year ago. Okay, maybe let's try doing this again. Okay, Leetcode 203. Remove linked list elements. Given the head of a linked list and an integer value, remove all the nodes of the linked list that has node.value equals value and return the new head. Example. Do I have to do this in place or can I make new nodes? It doesn't say you have to do it in place. Oh, and the number of nodes is really small too. You know, the easy way out is to do it not in place. Just make new nodes for everything. But I guess as a challenge, we could do it not in place later. So the easy way to do this, if you're not worried about... Well, I don't think we have to be worried about memory in this case because it says the number of nodes is max 50. So all we have to do is, like, let's say we're given this linked list, right? This stick right here, then we can literally start our own head node and then iterate through the linked list, make a current node parameter variable, and then if the current node has value equal to the given value, like value 6, then you just append it to here. Oh wait, no, remove all the nodes of the linked list that has node.value equal to the value. Okay, so yeah, you still iterate left to right through every single node, and if the value is not equal to the given value, then you add it to the new head. Yeah, that's literally it. Though you probably got to be careful with the nodes. Oh, there's some base cases here. So head, it could be null then. That should be fine. And then if we just don't append anything to the, the bogus head node in this case where all the values are illegal, and then we return the head.next, which will be null. So we probably gotta make it so that if head.next is equal to null, then return empty. Yeah, all right. Cool, let's do it the easy way first. First, let's do whole new nodes. Yeah. Okay, so let's do bogus head is equal to new list node. New, I don't need a new keyword, right? That new is for Java. List node, just gonna say head. Okay, the current node is equal to head. It's possible to be given an empty head, huh? Does optional mean that Python optional? How do optionals work? How do I tell if it's like null? The value can be none, not that the argument itself can be omitted. Oh, it can be none. So you do if blah is none, I see, okay. Should I write this down? I feel like this is useful information. Optional equals can be none. So if head is equal to none, if head, just base case, if head is equal to none, then we can just return empty. Yeah. Else we'd have to do work. Bogus head node is equal to a list node. Node is equal to head. Okay. While node is not equal to none, then you check the current value of the node. If node.value is not equal to the value, then you can append a new node to bogus head. Oh, I just realized you might also need, you probably also need to track the tail of the new linked list, right? You can't just track the head, because you have to keep appending to that node at the tail. Ooh, we might have to rename our variables to better variables. New head, new tail is equal to new head for now. Yeah, so new tail dot next is equal to this node dot value. Yeah. And then in the end you return new head dot next. I feel like this is it, no? If head is equal to none, then return empty. New head is equal to list node head. New tail is equal to, oh wait, am I forgetting the, I'm forgetting to update the new tail. New tail is equal to new tail dot next, yeah. The current new tail is equal to the previous new tail dot next, which is the one that you just set. And the new head should be completely unchanged. So return dot next. You know what? I'm just gonna submit this. Hello? Uh-oh. Oh no. Oh, I never increment the node. Dang it. node is equal to node.next. Is not a valid value for the expected return type. Oh, they're expecting either none or list node, huh? The example here is kind of misleading. If head is equal to none, then return none. Hey, let's go. Submit. There we go. Sick. Is it possible? Okay, let's change tactics. Is it possible to do this in place? Oh, I was kind of avoiding this because I know that the pointer stuff can get kind of messy. So again, we'll probably have a head node over here. Ooh, it's gonna get messy, the pointer stuff. It's always confusing for me. Okay, so we look at one first, right? We probably need a node to be like the current node. Like a variable to store the current node. So that'll be 1 at first. And then we're like, oh, okay, 1 definitely qualifies to be in the new new linked list. So we can point the head to it. And then now we have to somehow disconnect 1 from 2 while tracking 2 as a new node. So maybe we can be like, okay, new node is not this anymore, it's now 2. And then this connection is gone. Huh. Okay. And then we're like, okay, 2 works. So, oh, we have to track the tail too. Oh, we have to track the tail. The new tail. Oh my goodness. And then we're like, okay, 2 works, so connect the tail.next to here. And then the tail becomes this. Oh, so many arrows. So confusing. So tail is now here. And then we get to 6. We're like, okay, nope, no 6 please. Oh, and we have to disconnect 2 from 6. Oh, we have to do this every time. So disconnect 2 from 6. No, it becomes here. Oh, this is such a hassle, oh my gosh. Actually, no, it doesn't need to be this complicated, right? Am I overthinking this? I feel like I just need to iterate through the existing list. Maybe have a head node that points to here, and then start iterating. 1, 2, 6. Maybe I need like a previous pointer. That's a pattern, right? You have a previous pointer that points to your previous one, and then a current pointer that points to the current node that you're looking at. And then when the current node is not qualifying, then you can be like, okay, I need to remove this one. So your previous one will have to point to here now. Yeah, so this is gone. Oh. This edge doesn't really matter, right? It's like this node doesn't exist for all we care now because 2 jumps straight to 3. It doesn't matter what's 6. So we can probably just ignore this edge. And then we're like, okay, 3 becomes the previous. Well, you keep... Oh, I can just slide this. So, yeah, and then you move your thing like this. Wait. Oh. Oh no, the way I update my previous and current is kind of complicated after this one, huh? Is it just the current that moves up like that? Oh, I gotta be careful here. Okay. And then we're like, okay, 3 is fine. Move it up. 4. The previous. Go up. These are fine. The current is fine. This is fine. There's a problem here. 6 is not qualified. So we route 5 to the null node over there. Yeah. And then after this, after a sort of edge rerouting, we only increment our current. I see. Oh. So the important thing to know is that after we delete a node, we only increment the current pointer. Ooh, that's kind of tricky. Okay. Pollock says hi. Hello. Hi Pollock, nice to meet you. How are you doing today? Okay, let's start iterating. Let's do current node. Bogus head. Let's do a bogus head is equal to head. Current node is equal to, no, previous node is equal to bogus head, and then the current node is equal to the current head. Yeah. Doing good. Oracle is the Oracle company? Yeah. I know it's hard to believe because this problem is really easy. But I swear somebody who, I have a connection who recently interviewed at Oracle, and he was like, he gave me a list of questions that they interviewed with, so I'm trying them out. Already it's a bit trickier than I imagined, so not that easy. Okay, so while the current node is not equal to none, then you keep going forward. If the current node dot value, the value of the current node is equal to the illegal value, then you have to remove it. So this is this case, right? If our previous is here, and then our current is here, so we route previous.next equal to current.next. Yeah. Previous.next is equal to current.next. It's only one pointer we have to reroute, right? Yeah, easy, not always so easy. Yeah, to be honest, I feel like I've always kind of struggled with linked list problems because the pointers can get so confusing, especially with it's like double linked lists when the pointers go both ways. Did they land a job at Oracle? No, they went somewhere else, somewhere better. Yeah, I don't think they passed the Oracle interview. There were like 2 easy problems and 1 hard problem. Yeah. I'm probably gonna do the hard problem either next or in the next stream. Yeah. Okay, so it's only 1 pointer I have to get rid of, right? This one, the .next of the previous one becomes current.next, and then this this pointer here I don't have to take care of, right? Because this node is just lost forever. We don't even have access to it, so it doesn't matter. We have to be careful on how we increment our pointers here, right? We have to be like, we only increment the current pointer, not the previous one. Because we have to check the next one too. If this is a 6 as well, then we don't want to increment the previous one. Because then it becomes the same thing, right? Okay. So increment the pointers. Current is equal to previous.next, previous.next. Yeah, that's the only way we can kind of access this one, right? Previous.next. Yeah, I think so. Okay, and else what happens if they're both okay? So this is the case where it's kind of like this. So 4 is fine. Then we just increment both of them, right? To 4, 5. Okay. Else previous is equal to previous.next, and then current is equal to current.next. I only associate Oracle with Java, but maybe they're doing other cool stuff too. Yeah. You have no idea. I feel like a lot of companies are just secretly doing cool stuff. Like, a while back, Google was doing they had some video of them doing some weird computer vision and robotic stuff, right? They had a lab just full of robotic arms moving stuff, like Legos or whatever. But you don't really hear people talking about that. OpenAI is like secretly doing robotic stuff too. Like I have indirect connections that work at OpenAI working on robotic stuff, so that's kind of exciting too. OpenAI never talks about it though, but they are hiring people for it. Okay, the best playground for engineers. Man, I'm so paranoid. Did I cover all the cases? And then in the end I just return bogus head dot next. I hope. What happens if head is just nothing, like none? Bogus head is equal to head. Previous is equal to none. Current is equal to none. While current is equal to not equal to none, so it just skips everything. So we do bogus head dot next. Oh, this would fail. So bogus head dot next. Oh, hold on, it would not fail. Bogus head is equal to, why did I set this equal to head? This should be equal to some new bogus node, right? Node, bogus, and then bogus head. Previous is equal to bogus head. And then I should set bogus, it's next equal to head, right? Previous is equal to bogus head, current is equal to head. And then if head is none, bogus head dot next is none, so this will be fine. LKO IV6RL says, bro, how did you get these Oracle questions? I have connections. I knew somebody who recently interviewed for Oracle. That's basically it, and they told me the questions. Yeah, that's literally it. I'm also paranoid about all the edge cases. It's not like you get to run the code against 300 test cases in a real interview, right? Yeah, some interviews, they literally just have you write the code on a whiteboard and you can't run the code at all. One of my most torturous interviews was writing code on a whiteboard for like 6 hours straight. Maybe not 6 hours, it's more like 4 hours, 5 hours. that was just straight torture. I remember I got so upset during the interview, but I still pushed through it. I may have gotten some sympathy points for them. I feel like it was like the first, I was like, I have to have been one of the first interviews they've done in person, because it was a startup. They had me do like, similar to this actually, they had me do some linguist removal stuff. What else did they have me do? They had me do some simple system design stuff on a whiteboard. I don't remember what other question they gave me. They had me do some weird sorting problem too, involving multiple servers. But yeah, I remember I coded on a whiteboard for like 6 hours straight, and I was so mad. By the time the interview ended, I was thinking in my head like, there's no way in hell I'm gonna work here. And the interviewers, they were nice people, but they gave me not a good vibe. I think I said this on a previous stream before. In that particular interview, all of the people who interviewed me gave the vibe of a Indian dad giving me tough love while I was doing coding. And one of them, I remember, I was coding in Java at the time, not Python. I was coding Java on a board, and he asked me why didn't I do garbage collection in Java. And then I got paranoid and I was like, oh, damn. I didn't even know there was garbage collection in Java. Well, yeah, I don't know. And then he started like kind of chastising me kind of lightly. And then he looked it up himself and he was like, oh, wait, my bad. Java doesn't have garbage collection. You're right. Like, no, I was scolded for no reason. Yeah, I remember when I left the interview, I was like, there's no way in hell I'm gonna work here. If they give me an offer, I'm gonna reject the offer. which was a alarming thing to think about, because at that time I was jobless and very desperate for a job, and the interview was so bad that I was like, I'm unemployed now, but if I get the offer, I'm gonna reject it. Pollock says, what kind of product were they even building? They were building a AI data analyst. They're basically another ChatGPT LLM wrapper company. Yeah, trying to automate the jobs of data analysts. Yeah, I have no idea what goes on underneath the hood. Should I say the company name? Wait, I don't think I even remember the company name. Yeah, don't remember. I probably shouldn't say it anyways. Don't want to defame people. Okay, let's run this code. Chances are it doesn't work. I forgot the colon. Please, work. First try! First try, let's go! Okay, please don't jinx it. Let's go. I did it in place, baby. Probably for the first time ever. This is surprisingly simple, but it takes like a bit of thought to figure out that you actually need these two cases. Like, I would never have thought that, like, okay, I only increment the current one, not the previous one. Let's look at how other people did it. Yeah, they did a dummy thing like me. Dummy node .next is equal to head, previous is equal to dummy, current node is equal to head, while the current is still a thing. Current is equal to the value, then the previous .next is equal to current .next. Else, wait, oh, they did it a even simpler way. So what a cool animation. Is it part of Leetcode or did you make it yourself? Oh no, I did not make it myself. It's a extension. It's called Eldon Leetcode. Yeah, I saw it on Reddit. Somebody posted it on Reddit in the Leetcode subreddit, and that was funny, so I downloaded it. There's actually two versions. I don't know what the difference is. I think one was the earlier development one, and the other is the more polished one. I have them both downloaded, so there's actually 2 texts that appear on screen, and then 2 sound effects, so it sounds like it's so loud that it distorts the mic a little bit. But that was funny, so I kept it. My other extensions are Leet Rooms, which allows you to multiplayer battle people on Leetcode. Kind of like hosting a Leetcode contest yourself, but it's just you and your friends. Are you a new grad, bro? Nope. I graduated years ago. Wait, how long did I graduate ago? 4 years ago? Yeah, 4 years ago. I am a working engineer now. Honing my Leetcode skills so I don't forget stuff. What are they doing here? Previous.next is equal to current.next. Guess that makes sense. Else, previous is equal to current. I don't understand what they're doing. Okay, here, let's do it like this, right? Let's say you have 1 here, and then a 6 over here, 6, and then a 2 over here. So 6 is the illegal value. And then your previous is here. And then your current is here. What are they doing here? Okay, if current value is equal to value, okay, that's true. Then previous.next is equal to current.next. Okay, so you remove this, and then you do that. Else previous, so you don't do this at all. And then current is equal to current.next. Oh, I see. So they're saying you increment the current one no matter what. And then you only increment the previous one if you don't remove value. So it's basically what I did, but a bit simpler. Yeah, they just took this line out, right? Current is equal to previous.next to happen no matter what. Like that. Yeah. So it's basically what I did, except cleaner. Yeah, that's an optimization you can do. And somehow it's slower. I love Leetcode. Huh. What should we do for the rest of the stream? I think I want to do the next problem next stream. I want to keep this stream kind of chill. Should we do some strudel? I haven't played that track I made a while back in ages. Do you guys know what strudel is? Let me get some starter code out. Oh, I literally forgot how to... I'm pretty sure I already forgot how to play this track. Strudel. Maybe I'll just practice this track and then I'll leave. How do I... Oh. Where are the settings so I can make it look cooler? Nope, that's not it. Well, yeah, where did all the settings go? Here. I want arch. Oh, do I remember how to do this? Let me know if it's too loud or whatever. I've been watching way too much Switch Angel recently. So basically I have a super saw synth right now that's playing the notes F, D, and C and followed with a pause. And then I'm gonna add some increase the unison, so it's 2 synths playing at once. It sounds a bit thicker. I'm gonna enable the drums underneath here. We have a snare and some hi-hats going. I totally forgot to do this. Hold on, let me get my notes underneath here. Bum. Wait, let me check my notes on how this routine goes again. I literally forgot everything. So apparently I have to put in a kick drum. Kick drum 1 every 4. BD 1 times 4, what does that do? BD 1 times 4. Right. I'm gonna comment out the drums over here, make the synths perhaps louder, and then add some wobble effect to the synth. Oh, I remember this part. Okay, we have some melody going in. I'm just uncommenting stuff. I guess I need to make the synth a bit less aggressive now and then comment out the drums. Sorry, make this a bit quieter. Okay, I'm done. I am going to end the stream. Thanks everyone who came. I appreciate. Thanks Proc63, Pollock, whoever else is here. I forget. Okay, I'm gonna go now. Bye. We'll finish the Oracle questions I got sometime this week.
Thank you.